Good morning, students. In this video, we are going to learn how to prove the basic proportionality theorem. In a short form, we used to call BPT. So, it's given in a basic proportionality theorem. If a line drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So, according to the basic proportionality theorem, there are three sides in the triangle, that is a AB, AC, and then BC are the three sides of a triangle we have taken. In that, we are drawing a line PQ. Here I have used a black color. That line PQ is parallel to the BC we have taken. So it's given a line PQ is parallel to BC is given. So if it is parallel mean we have to prove the other two sides are divided in the same ratio. So divided in the same ratio mean how to prove. So for proving the theorem, first we have to write the statement clearly without the mistake, and then we are writing the given statements. So in this they have given triangle ABC. In this triangle ABC, PQ is parallel to BC is given. Now what we have to prove? We have to prove the sides, the remaining two sides of a triangle are proportion. So here we have considered only the side BC alone. Apart from the BC, what are the two remaining sides are there mean AB and AC. In that, because of the parallel line PQ, we are getting a AP, PB, and then AQ and QC. So we have to prove. For our better understanding, I have given the colors. So red color, that is a AP by PB, which is equal to AQ by QC. So you no need to memorize the alphabets. Whatever alphabet we have given in the figure, same thing we can use it to prove the theorem. So when you observe here in the figure, the first partition, that is a AP by PB, which is equal to AQ by QC. That only we have to prove. To prove this theorem, I am getting help from the area of a triangle formula. So for finding the area of a triangle, what is the formula? Half into base into height. So I need a height. To get the height, we are constructing a perpendicular line. So for that, we are writing the construction. So when you observe the figure, I'm taking a green color line. The green color line PM, we have drawn perpendicular to AQ. And then I'm constructing a next perpendicular line, that is a NQ NQ is perpendicular to AP. So we have constructed two perpendicular lines. The nature of a perpendicular lines, always they intersect at 90 degree. Now we are going to proceed further with the proof. So first we are paying concentration of the left hand side. Left hand side is AP by PB alone. We are going to pay the concentration. So AP, that is a part of a triangle APQ. So I'm using a red color to show the triangle AP. Yeah. So here is a triangle APQ. What is the area of a triangle APQ? So we can write directly the area of a triangle. Area of a triangle, if you know the height, or otherwise if it is a right angle triangle, we can use the formula half into base into height. So according to the APQ, half into the base, always whatever we have written, whatever we want to prove, that will be the important. So for my convenience I'm bringing, then we can write easily. So left hand side I have to bring, this is only for my convenience I have written. After completing we can erase it. So for my convenience I have to bring only the AP. So we are considering AP as the base. If AP is the base, what is the height? Yes, the height is the one more red color line already we have drawn, that is the NQ. And we are giving the number for this as a 1. Now the next one I need PB. So I'm giving the blue color. PB is available here. So according to our target, AP and PB, PB is available here, but I have to use the same height. Why do you need the same height? Mean then only while dividing the height will be cancelled, then we will reach our target. So if I want the same height, I have to take a triangle BPQ triangle, and here is the altitude, and there is no necessary, the height of a triangle always should be inside the triangle. It may be available outside the triangle also. So here in the triangle PBQ we are going to find the area, that is half into the base. Here according to this figure, the base is PB and the height is NQ we got. So this is the second equation we have marked. Now the left part is over, but still I didn't get the AP by PB. When we will get the AP by PB? When we are dividing the first equation by second equation only we will get. So we are dividing 1 by 2. So what is the first one? Area of a triangle APQ by area of a triangle PBQ. So we got in the first equation, which is equal to half into AP into NQ by, in the second equation we got half into PB into NQ. Now division mean we can simplify, so we are striking the common thing. Half and half get cancelled, NQ and NQ got cancelled. So area of triangle APQ by area of a triangle PBQ, which is equal to AP by PB. This is the third equation. So we got a left hand side of our proof alone. Still we have to get the right hand side. So we are going to try for the right hand side. So according to our target, what is the right hand side mean? I have to get AQ by QC. So for our convenience, I'm bringing one more time that AQ by QC to the right hand side of my triangle, then I can reach my target easily. Okay. This is only for our convenience only. It's not necessary. If it is available to my side me, I can check it my target often. Okay, now the first numerator is a AQ. I'm using a orange color. Where is the AQ? So AQ is it triangle? No, it is one of the side of a triangle APQ. So first we are finding the area of a triangle APQ. So what is the area of a triangle? Same half into base into height. So here 90 degree is arising from AQ. Already we consider the NQ, so you no need to consider again. If AQ is a base mean, PM is a altitude. So half into AQ. AP also the base, but we considered already for the left hand side. Here I need for the right hand side AQ. So I consider AQ as a base multiplied by the height PM. This is the fourth equation. Now the next target I need is a QC. For the QC, I'm using a red color. Here is the QC, and I'm taking a triangle PQC. For the triangle QPQC, we have an altitude here. So in this triangle also, the altitude is not available within a circle. It is exterior of the, within a triangle. It is exterior of the triangle. Now we are going to find the area of a triangle PQC, which is equal to half into always base. Here is the base QC multiplied by PM, which is considered as the fifth equation. So whatever we have done for the previous thing, same thing. After getting the first equation and the second equation, we have divided. So same thing here also, we are dividing. Now this is not needed. After getting the answer, we will erase it. Okay. Now we are going to divide 4th by 5th. Okay. So according to the fourth one, left hand side area of a triangle APQ, and then denominator area of a triangle PQC, which is equal to the right hand side half into AQ into PM. By half into QC into PM. Now we are going to simplify the calculation. Half and half get cancelled, PM and PM got cancelled. So we got the final answer, that is the area of a triangle APQ by area of a triangle PQC, which is equal to AQ by QC. So I'm going to check my target. I have copied in a rough column whether I reached or not. I'm going to check. Okay, yes, I got it. So this is the target AQ by QC. I got it. Now when you observe the third one and the fifth one, if left hand side is equal, mean we can say automatically right hand side also equal. I have to prove. Let me bring a target for our convenience again. One more time down, then I no need to scroll it. So I have to prove AP by PB, which is equal to AQ by QC. When you observe, we got AP by PB, AQ by QC we got, but left hand sides are different. Here APQ and APQ is correct, but denominator is different. So if you prove the denominators also equal, automatically the left hand side is equal, then we can say simultaneously right hand side also equal, then we will reach the target. So now we are going to observe the figure. Only for our convenience, I am bringing a triangle to our present place. It's not needed because I can't scroll often, so I brought the triangle. So when you observe the BPQ and PQC, that is a blue color triangle and the red color triangle. These two areas are equal. If you prove, automatically the left hand side will be equal. So when you observe the blue color triangle and the red color triangle, both the triangles have a common base. Which is a common base? PQ is a common base and they are between the common parallel also. So in ninth standard we have learned the triangles have a common base and within the same parallel PQ and the BC mean we can say both the triangle areas are same. So according to that we are writing triangle PBQ and triangle PQC have common base and within same parallel line so we can say area of a triangle PBQ which is equal to area of a triangle PQC. So this particular point we are applying in the third and the sixth. So from the third, sixth and the seventh we are getting automatically the left hand sides are equal because area of a PBQ and area of a PQC are equal. Already we know numerators are equal. Now we prove the denominators are also equal. So left hand sides are equal mean automatically the right hand side of a 3 and 6 will be equal. So AP by PB which is equal to AQ by QC. This is very important theorem for the 10th standard board exam. I hope so you understood the theorem how I explained. Let's meet in the next video. Thank you all. Bye bye.